Your headlights are not actually failing. In many cases, the diagnosis itself is the problem. A component costing only $3, available at hardware stores across America, can permanently stop headlight flickering in less than 15 minutes. It is not a new bulb. It is not a relay. It is not a $600 alternator repair. It is not the complete rewiring service that some drivers are quoted. In 1972, a retired electrical engineer from Delco Remy uncovered what he believed was the real source behind 80% of flickering headlight complaints. The solution was inexpensive, simple, and long-lasting. According to the account, it was so effective that it threatened a large portion of the vehicle electrical repair business. The auto electrical service sector produces $7.8 billion each year in the United States alone. Yet the component capable of resolving many headlight complaints costs less than a cup of coffee. This was not presented as a shortcut. It was not a temporary workaround. It was described as a diagnostic step that mechanics were trained to overlook. The story begins in 1972. Inside a failure analysis laboratory at Delco Remy in Anderson, Indiana, a senior electrical systems engineer named Gerald Vanny was assigned a critical task. For those unfamiliar with Delco Remy, the company served as General Motors' electrical component division. For decades, alternators, starter motors, and headlight electrical systems installed in GM vehicles passed through that operation. Vanny was not focused on designing new products. Instead, he was investigating why existing components were being returned. Dealerships nationwide had been sending back headlight assemblies labeled as defective. Reports cited flickering lights, intermittent operation, and premature bulb failures. The standard warranty procedure was straightforward. Remove the assembly, return it to Anderson, install a replacement, and process the associated costs. Vanny's responsibility was to disassemble the returned units and verify the reported defects so warranty claims could be completed. He began examining the assemblies one by one. The bulbs tested correctly, the relays operated normally. Wiring harnesses showed no damage. Resistance measurements across internal circuits remained within specification. Again and again, the same outcome appeared. Over a period of 5 months, he inspected 340 returned assemblies. 78% showed no internal failure whatsoever. The bulbs functioned. The relays functioned. The wiring remained intact. Nothing inside the assemblies appeared defective. When the component itself was not at fault, Vanny followed the electrical path beyond the housing. Every headlight assembly depended on a ground wire connected to the vehicle chassis. A single wire attached to bare metal completed the return route back to the battery. Without that path, electrical current could not properly complete the circuit. The result could be flickering lights, dim illumination, or complete failure. Vanny traced the ground connections on every host vehicle associated with the returned assemblies that remained within the dealership network. The same condition appeared repeatedly. Corrosion, green oxidation, covered the copper ring terminal where the ground wire met the chassis bolt. Beneath the connection point, a thin layer of calcium deposits and road salt contamination coated the metal surface. That corrosion increased electrical resistance. Higher resistance created voltage drop. Voltage drop caused the bulb output to fluctuate. The headlight flickered, not because a component had failed, but because a single connection point had become contaminated. Vanny cleaned the contact area using a wire brush. He then applied a thin layer of dielectric grease to the restored surface. After reconnecting the ground bolt, he switched the headlights on. The lights remained steady. High beams were stable. Running lights were stable. Every circuit, depending on that ground connection, returned to normal operation. He repeated the procedure on 80 vehicles within the dealership return system. Every case was resolved. Next, he calculated the treatment cost. The wire brush represented a one-time purchase. A tube of dielectric grease cost $3 and could service more than 40 vehicles. Vanny prepared a detailed service bulletin. The recommendation was simple. Inspect and treat ground connections before replacing any headlight electrical component. He submitted the document to the GM Service Economics Division during the fall of 1972. According to the account, the bulletin never reached dealerships. It never arrived in service departments. Consumers never saw it. Vanny was informed that the recommendation did not fit existing service labor allocation models. In corporate language, that statement carried a clear implication. A $3 repair could eliminate diagnostic and replacement jobs worth between $180 and $600. The numbers were straightforward. Vanny requested reassignment. In 1975, he departed from Delco Remy. The account concludes that he did not leave because his findings were incorrect. He left because the findings created a problem. The information did not begin with Gerald Vanny, and it did not disappear after his departure. Again and again, the same findings emerged. Again and again, they were pushed aside. Robert Bosch, GmbH, released an automotive electrical maintenance guide intended for European repair facilities. In that document, inspection of ground connections and application of dielectric grease appeared as the very first diagnostic action for any abnormal lighting circuit behavior. It was not listed as a secondary measure. It was not buried in a note. It stood at the beginning of the procedure. Within 2 years, the manual became standard equipment in service centers throughout Germany and France. That approach was never incorporated into American ASSE certification instruction, not in 1979, not during the years that followed, not at any point afterward. The Society of Automotive Engineers later issued a peer-reviewed technical paper examining intermittent electrical failures in passenger vehicles older than 5 years. The study identified corrosion at ground points as the largest single source of those failures. Its formal recommendation called for manufacturers to apply preventive dielectric treatment to every ground connection before vehicles left the factory. No manufacturer implemented the recommendation. The paper circulated through engineering collections and academic institutions. It never appeared in consumer-focused automotive publications. The Automotive Research Center at the University of Michigan carried out a controlled investigation involving 200 vehicles brought to independent repair shops because of headlight electrical problems. Technicians first determined and documented the actual cause of each complaint before performing the repair normally recommended by the shop. The findings were striking. 74% of all flickering headlight incidents were traced solely to corroded ground connections. Not failed bulbs, not defective relays, not deteriorated wiring, just a contaminated bolt attached to a fender. Across those 200 repair visits, the average charge from repair facilities reached $220, yet the real expense required to correct the true issue in 74% of the cases was less than $3. Another study focused on fleet maintenance in Ontario, Canada. The project included 1,800 municipal vehicles, among them police cruisers, transit buses, and utility trucks. A program was introduced requiring yearly dielectric treatment of ground connections throughout all lighting systems in the fleet. Within 3 years, service calls related to lighting problems fell by 81%. Projected savings over 5 years reached $2 million. The results were published in a Canadian journal dedicated to municipal infrastructure. They never appeared in any American automotive trade publication. An independent automotive electrical channel later collected diagnostic information submitted by viewers. More than 500 vehicles experiencing headlight flicker were included. Participants were instructed to inspect and clean ground connections before replacing any electrical component. 69% of all reported flickering cases were completely resolved using only ground cleaning and dielectric grease. No new parts were installed. No repair shop visit was required. No invoice was generated. Every source pointed to the same outcome. The $3 solution worked. It had worked all along. The question then became how a $7.8 billion service industry could continue when the remedy cost less than a sandwich. According to the account, the answer was that the system was not structured to reveal the solution. It was structured to move past it. The first barrier involved diagnostic software. When a technician connects a scan tool to a vehicle, the system evaluates components. It checks bulbs. It examines relays. It analyzes control modules. It measures voltage at connectors. What it does not evaluate is resistance at the ground contact location. A corroded ground typically produces no diagnostic trouble code. As a result, the scanner may report no fault found or identify the nearest replaceable part, such as the bulb, relay, or switch. Those are the items capable of generating a parts invoice. The software, according to the account, was never updated to assess ground connection quality because that condition did not create a billable replacement item. The second barrier was the training process. The ASSE certification program provides credentials for most working automotive technicians in the United States. Its electrical systems curriculum teaches testing procedures for components, modules, wiring harnesses, connectors, and fuses. It does not contain an independent procedure dedicated to diagnosing ground connections and applying dielectric treatment. As a result, a mechanic can be fully certified and highly capable while still carrying a gap in foundational training. They were not instructed to disregard the ground connection. They simply were never taught to inspect it. The third barrier existed on the retail side. Dielectric grease is available in auto parts stores throughout America. It can be found in the electrical specialty section. Yet, it is not displayed alongside headlight bulbs. It is not packaged within headlight replacement kits. It is not recommended on bulb packaging. The product is there. The recommendation is not: a driver enters an auto parts store because a headlight is flickering. They walk past a $3 tube capable of addressing the underlying issue. Instead, they leave with a $28 bulb that does nothing to correct it. The item exists on the shelf. What has been removed is the connection between the item and the problem. No phone call was required. No formal directive was necessary. The system simply never linked the two together, and according to the account, it still does not. Consider what that separation may have cost. A typical diagnostic appointment for a flickering headlight ranges from $120 to $220. Parts commonly replaced during that visit, including bulbs, relays, switches, or wiring harness sections, add another $80 to $350 depending on the vehicle. The average total reaches $260 per occurrence. Because the ground connection often remains untreated, the complaint returns. The estimated frequency is 1.5 events during a vehicle ownership cycle and 3 vehicles across an average driving lifetime. That calculation places the total at $1,170 for each driver. Across 230 million licensed drivers in the United States, even if only 40% experience headlight flicker at some point, that equals 92 million drivers spending $1,170 each. The cumulative figure exceeds $17 billion in unnecessary costs across a single generation of American motorists. Meanwhile, one $3 tube of dielectric grease can service 40 vehicles and remain usable in a toolbox for 10 years. The procedure itself is straightforward. 4 items are required: dielectric grease from any auto parts store for $3, a small wire brush or a piece of 220 grit sandpaper costing less than $1, a basic socket wrench set already found in many toolboxes, and painter's tape for protecting nearby surfaces. The first step is locating the ground connection. Every headlight assembly includes a ground wire. It is the black wire extending from the headlight connector toward the vehicle body. Follow that wire. It ends at a bolt secured directly to exposed metal on the chassis or inner fender wall. That bolt serves as the ground point. Next, disconnect the ground, remove the bolt, and separate the ring terminal from the chassis. Inspect both contact areas carefully. Corrosion will often be visible. Green deposits, white residue, or dark oxidation may appear on the copper terminal. Calcium buildup and salt contamination may be present on the metal beneath it. According to the account, that corrosion is the source of the issue. The next stage is cleaning both surfaces. Use a wire brush or sandpaper on the ring terminal until bright copper is visible. Do the same on the chassis contact area until clean metal appears. Approximately 60 seconds per surface is sufficient. Then apply dielectric grease. Cover the ring terminal and the chassis contact point with a thin, even coating. The grease remains non-conductive across the surface, yet allows complete metal-to-metal contact, where compression occurs after tightening the bolt. It blocks moisture and oxygen from reaching the connection. According to the account, this is why the repair not only works immediately, but also prevents future corrosion. Afterward, reconnect everything. Attach the ground wire back to the chassis and tighten the bolt. Hand tighten first, then add a quarter turn using the wrench. Apply one final layer of dielectric grease over the bolt head itself to seal the assembly against water intrusion. The final step is testing. Switch on the headlights, the flickering is gone. Activate the high beams, they remain steady. Check the running lights and turn signals within the same housing, they remain steady as well. Every circuit sharing that ground path has been restored. The entire process requires 15 minutes per side, 30 minutes for both headlights. With the dielectric seal in place, the treatment is described as lasting between 8 and 10 years in any climate, including regions with heavy winter road salt. The account contrasts this with a driver who paid $340 for a relay and wiring harness replacement at a repair shop. 18 months later, the flickering may return because the ground connection was never addressed. In comparison, the same root cause could be corrected in a driveway within 30 minutes using a $3 tube that remains useful for another decade. According to the narrative, this was the difference Gerald Vanni documented at a Delco Remy laboratory in 1972. The chronology remained consistent. Vanni identified it in 1972. Bosch published it in 1979. The SAPI confirmed it in 1986. The University of Michigan study demonstrated it in 2004. Ontario implemented it on a large scale in 2014. More than 500 independently reported vehicles reinforced it in 2021. 6 separate confirmations spanning 49 years. The conclusion remained unchanged. The ground connection was identified as the solution. The $3 tube was identified as the tool, and according to the account, a $7.8 billion service industry spent decades ensuring consumers never associated one with the other. If this information may help someone dealing with flickering headlights, share it with them. It could prevent an unnecessary $300 repair bill. The next overlooked issue, according to the account, may cost drivers 10 times more. Please leave your thoughts about this content in the comments below. Thanks for watching. See you in the next one.